student. Today we will continue to our chapter 1.5, which is density. Are you ready? For concept and formula, the fundamental. Okay, the first one, we need to look our definition of density. This is important. You must remember, maybe come out in your exam. What is density? Density is an intrinsic physical property that measure how tightly packed the particle of matter are in object. Okay, take note what that I highlight. Okay, then definition. Okay, mass per unit volume of substance. Okay, so this is our formula that you need to remember and memorize it. Okay, density, this is our symbol for density, and then density equal to mass over volume. So density, I will write here, density equal to mass over volume. M over V. Okay, music video. That's it. That the tips lah. So unit, SI unit is kilogram per cubic meter. Kg over M. Okay. Common unit is gram per cubic centimeter. So, what we need to know for this point is the density value is a constant. Okay. Okay, look at that one is a constant for pure substance under fixed temperature and pressure. That means the density value is a constant for the pure substance under two types, which is temperature and pressure. Both of them is fixed. Okay. Alright, so we move to our measurement and calculation technique. What we want to find? Okay, to find density, you must accurately determine our mass and volume. So, how to get our volume? For regular shape, we measure dimension lah usually. So, what we have is LWH, our radius lah we use. Okay, wait Okay, so we have LWH WH radius. So we're using a ruler or vernier caliper and apply the geometry. So you must remember that formula we will use for this type to get our volume is a volume equal to length and then time with width and then time with height. So for a cubit that's a regular shape. For irregular shape, okay, what happened for irregular shape? Okay, we use a water displacement method, which is we using a measuring cylinder or eureka. Okay, the principle we need to memorize is the volume of displaced water is equal to volume of the object. Okay, you must remember, okay, the formula here. This one, you must remember for object must be started from final and then we minus with initial. So that's the formula. Okay. So for operative of definition of density pula, we need to know and to understand what the definition is. Okay. Density. Okay. Okay. For this part, we can say that density defined as the mass per unit volume. We need determine by dividing the mass. Okay, measure by a balance. By the volume, measure by a displacement method or geometric formula. Again, density is defined as the mass per unit volume, determined by dividing the mass that measured by a balance by the volume measured by the water displacement method or geometric formula. Okay. Okay. For this part, we have a principle of flotation and density changes. Flotation, sinking or floating, it depends entirely on the comparison of the object density to the medium density. We have three factors that affecting our density that I already highlight for you. The first one is temperature, and then the second one solutes, and the third one is water anomaly. Okay. Before we go to the explanation, I will recap back for you the formula of density. Density equal to mass over volume. MV, right? Music video. So, okay. So look at here. Increasing temperature will cause the thermal expansion. So it will make that volume, our volume, increase. Okay. So, since mass is a constant, okay, this one is a constant, okay, constant. So, density will decrease, okay, it's a logic lah. Okay, normally when we do for this formula, we look at for this formula, when a volume will increase, this one is the below one, right? The below one. So, when the volume is increased, it automatically this sides, left side here, will opposite the arrow. This one up, upper arrow, right? The arrow is up. This one arrow must be downward. Okay, so it's a logic. So that the tips how to you remember to recap the factor of effective density. For this one, this for one lah. Okay, for solute case pool. Again, for solute, adding a solute like salt significantly increase the mass, okay, of solution, causing the density to also increase. Okay, for second part, I write here, we rewrite again our formula, density MV, music video, okay. So, here we look at here, okay, when we add on our salt, it significantly increase our mass. Okay, when increase the mass, okay, the density also increase. Okay, so look at here. When that's up, so that's mean the left side also same lah, arrow. Okay, this one is opposite, right? This one is at the below one, and then this one is upper one, right? So that's why the arrow is opposite. Okay, for this one, the arrow is same lah, because same side. Same, the upper side, both of them. Okay. So for the third one is water anomaly. We have water reach maximum density at 4 degrees Celsius. Ice density is lower, float on water. Okay. So just easy one, right? For this part, we have a principle of flotation and density changes. Flotation is governed by the comparison of the object density to the medium density. Okay, we look at the relationship, the phenomenon, and explanation. Okay, when density object is less than density liquid, okay, look at this area. Okay, the phenomenon happen is float. So the object is less than the fluid is displaced. And then when the density object is greater than density liquid, the phenomenon is sinks. The object is dense than the fluid it displays. Okay. Before that it's less than, and then for this one is a denser than the fluid. Okay. So layer liquid, we have density low on top. Liquid will arrange themselves from the less dense, okay, to the most dense, okay, to the from the top to the bottom. Alright. So this one is just same case that we already discussed just now. Alright. This one is just same lah. We need to remember first our formula density, and then we can know lah the temperature, what happened For impurity, what happened. For water, what happened. Okay, so just same. Alright. Then for this one, for real world application, we have application density mechanism. We have submarine. Okay, for submarine, we control what? We control the average density by adjust or water or air in a ballast tank. And then what happened for this part? Our density will increase to deep, and then our density decrease to the surface lah. And then for the second one is Dead Sea, water is highly dense due to the extreme salt concentration. So density is greater than 1.2, which is greater than human body average density. And then hot air balloon, we have what? The hot air inside the balloon density is low and is lighter than the cool air outside. The salinity is high, creating lift. Life jacket, we have what happened to for this situation, made of very low density material to ensure that average density is less than water. Okay, so that's all. Thank you. So if you don't understand, you can directly ask and comment. Okay.
Hello everyone. Okay, you have already learned the theory related to the topic of density. So now let's continue and learn how to calculate density using a very simple formula that you have learned before. We are going to explore how to calculate density step by step using this formula. Still remember or not, what is the formula of density? Density equal to mass over volume. Okay, so this is the main formula for this topic. Okay, so another formula that you need to know is V object equal to V final. V is what? V is the volume of the object. When we want to know the volume of the object, you need to calculate V final minus V initial. Okay, so this formula also can be used when we want to know the mass of the object. Okay, so the mass object equal to final mass minus initial mass. So same lah. Okay, so we continue with the first example, the simple example. Okay, so get ready with your calculator now because we want to calculate this question. Alright, okay, so example 1. An empty measuring cylinder has a mass of 200 gram. So this is the first information that we get. Okay, so when 50 cm cube, okay, so this is the volume is poured in the when 50 cm cube of liquid A is poured into it, the total mass become 250 gram. Total mass. So the question asks for the what is the density of liquid A. So this is the question 1. Okay, so from this question, what the information that you get? First of all, you have the mass of 200 grams. So this is the mass initial, right? And then when 50 cm cube of liquid A, so this is the volume, I volume. Okay, so the total mass become 250 gram. So the total mass. So this is the in final mass. Okay, so the question 1, the density of liquid A. So what is the formula of density? Wait, okay, density equal to mass divided by volume. Okay, so from this question we already have the volume, right? But for the mass we have two value of mass. final and initial, but we want the mass, not final, not initial, right? So use the formula that we have learned before. So mass final minus mass initial divided by the volume. The volume. So no need lah, I want to rewrite the volume 50 centimeter cubic. Alright, so next step is, what is the mass in final? 250 gram minus 200 gram divided with 50 cm cube. Okay, so use your calculator. Minus 200 become to 50 gram divided with 50 cm squared. So use your calculator if you don't know how to calculate. Okay. So 1, what's the unit for density? Gram over cm cube. So this is the final answer for this question. Rewrite it. Okay, so we rewrite it. Therefore, the density of liquid A is 1 gram over centimeter cube. So this is the answer. Easy, right? Okay, so let's continue with the example 2. Okay, so example 2 is about an empty measuring cylinder has a mass of 230 gram. Okay, this is the first information that we have. When 40 cm cube, okay, this is the volume, is added, the total mass become 290 gram. Okay, so the question asks for the calculate the density of liquid B. Okay, so actually the example 2 is same like the example 1. So let's we do it together. So first information that we have is mass of 230 grams. So this is the mass, initial mass. Okay, correct. Next, 40 cm cube is 40 centimeter cube is volume. Yes, correct. The total mass become 290 gram. This is the final mass. Okay, so density of liquid B. So the question asks for the density. Okay, so let's we list down the information that we have so you did not confuse lah. Okay, so what is the first information that we have? Initial mass. Okay, so initial mass equal to 230 gram. Final mass equal to 209 gram. The volume is 40 centimeter cubic. Okay, so what is the formula of density? Still remember or not? Need to remember. Okay, density equal to mass over volume. So from the information that we get from the question, you have volume. How about the mass? You have two types of mass, so you need to use the formula like final minus initial. You know, right? Okay, so let's we do it together. And final minus M initial, M is mass, divided with the volume. The volume for this question is 40 cm cube. Okay, so continue. And final mass is 290 gram minus 230 gram over 40 centimeter cube. Use your calculator. Equal to 60 gram over 40 centimeter cube. So equal to 1.5 unit. Please write the unit. If not, your answer is incorrect. So this is the final answer, 1.5 gram per centimeter cube. So rewrite it again. The density of liquid B is 1.5 gram per centimeter cube. So this is the final answer. Easy, right? Okay, next we would like to continue next question, which is question for example 3. For this example is a little bit challenging rather than example 1 and example 2, which is the two example before is like straightforward question only. But for this question, you need to thinking more because it's a little bit challenging. But never mind, it's a little bit only. I will explain to you step by step for answer this question. Okay, so let's start now. Okay, so for this question, a measuring cylinder has a mass of 320 gram. So this is our first information. Okay, when 13 centimeter cube, okay, of liquid C is poured in, the total mass is increases to 390 gram. Okay, next, then when another 20 centimeter cube of liquid C is added, and the mass become 420 gram. Find the average density of liquid C and compare it with the density of water. So for this question, we have two questions to answer. First, we need to find the average density of liquid C and we need to compare with the density of water. Okay, so we have two sub-questions. But never mind, we'll do it together. Okay, so for this question, we are told that an empty measuring cylinder has a mass of 320 gram. Okay, when we pour it into 30 centimeter cube of liquid C, the mass increases to 390 gram. So the first thing we need to do is to find the mass of the liquid itself. So for step 1, we need to find the mass of liquid. Okay, so how to find it? Okay, use the same formula that we have learned before. It is final mass minus initial mass. Still remember, right? Okay, so what is the final mass? 390 gram minus 320 gram. So use your calculator. You will get 70 grams. So it's the mass of liquid. Alright, so now we can calculate the density using the formula. So the formula of density. Density equal to mass over volume. So the mass we get is 70 gram over the volume is what? 30 centimeter cube. So we will get 70 over 30 equal to 2.33. The unit, don't forget about the unit, gram over centimeter cube. Okay, so this is the first step. Okay, so for the second step, which is name it as step 2. Okay, so from the question we know that we add another 20 centimeter cube of liquid C. Okay, so the mass now become 420 gram. Okay, so again we need to find the mass of this extra liquid by subtracting. So for the step 2, we need to find the mass of extra liquid. So same formula like before. Okay, final mass minus initial mass. Okay, so what is the final mass? 420 gram. Yes or no? Yes. Minus 390 gram. Okay, minus it 42 equal to 30 gram. And then we also need to calculate the density for this second portion. Okay, so formula density it's okay, just do it step by step. Density equal to mass over volume. Okay, our mass is 30 gram over 30 gram over what? 20 centimeter cube. Okay, 30 divided by 20 equal to 1.5 cent. Don't forget about the unit. 3 over centimeter cube. Okay, so this is the density for the extra liquid. Okay, so the question asks to find the average density of liquid C. So we need to take both value and find the mean because it asks for the average density liquid. So we need to find the average first. So I use here. Okay, so how to do this? You need to find the average. Average density. We need to find the average. So average you need to, average to divided by all. But in this question we have only 2 liquid, right? So what we need to do is need to 2.33 need to plus 1.50 is 1.5 or 1.50 is okay. Okay, divided by, because we need to find the average, so divided by 2 because we have 2 liquid. Okay, so 2.33 plus 1.5 over 2, so we get 1.92. Don't forget the unit. What is the unit of density? Gram over centimeter cube. So this is the average density. But we have another question to answer. Compare it with the density of water. which is the density of water is 1.0 gram over centimeter squared. So we need to compare it. I want use pink color lah. Okay, so because of 1.92 gram per centimeter square is greater. Okay, so 1.92 gram per centimeter square is greater than 1.0 gram. This is the density of water. So it means that the liquid C, okay, the liquid C is denser than water. Denser than water, and it would sink if placed in water. Okay, so that's all for this question. Still easy, right? Okay, so we will do next exercise together, but for now that's all from me. Bye.